Keeping it going with number 5, the limit as x approaches 9 of x minus 0 over square root x minus 3. If you plug in 9, then we're going to get, I shouldn't say equals. If we plug in 9, we get 9 over 0, right? Because square root of 9 is 3, minus 3 is 0. So we have to be careful here because we can't apply L'Hopital's rule, because L'Hopital's rule only applies when you have infinity over infinity or 0 over 0, not 9 over 0. But when you take a non-zero number divided by 0, that implies that there's a vertical asymptote. So what we should do instead here is we should plug in 8.9 and we should plug in 9.1 and see what happens. So if we plug in 8.9, we get 8.9 over square root 8.9 minus 3. Okay. So you know that square root 8.9 is going to be close to 3, but it's going to be smaller than 3. So what we basically have here is we have 8.9, and it's going to be divided by 0, but that 0 is going to be a negative number because this number is smaller than this one. So when we divide by zero that's or when we divide by something close to 0 that is negative, then that is going to go off to negative infinity. Now if we do 9.1, over square root 9.1 minus 3, okay, well this is going to be 9.1 divided by 0, but because it's square root 9.1, it's going to be slightly bigger than 3, so that's going to give us a positive number that's close to 0, so that's going to approach positive infinity. So one of them approaches negative infinity. On one side we approach negative infinity, on one side we approach positive infinity, so we say this limit does not exist. All right, limit as x approaches 0 of sine x over x. If we try to do sine 0 over 0, that's going to give us 0 over 0. So that tells us we can use L'Hopital. So we'll do limit as x approaches 0 of cosine x over 1, which is going to be cosine 0 over 1, which is just going to be 1. So that limit is equal to 1 by L'Hopital's rule. Take the derivative of the top, take the derivative of the bottom, and then reapply the limit. Okay, limit as x approaches pi over 2 of cosine x minus 0 over x minus pi over 2. On your packet, it has this listed as cosine pi over 2, but cosine pi over 2 is just equal to 0. And again, then, if we try to plug this in, we are going to get 0 over 0, which tells us, L'Hopital, the derivative of cosine is negative sine. The derivative of x is 1, so we get negative sine of pi over 2 over 1. And that's going to be negative 1 over 1, which is just equal to negative 1. And then last, we have the limit as x approaches infinity of x squared plus 4 over x minus x squared. So if we plug in infinity, obviously we just get infinity over infinity, right? So we can apply the L'Hopital's rule, and then I'll talk about another way to think about this in a sec. So we get 2x on top, and then the derivative of x minus x squared is 1 minus 2x. Okay, if we were to plug in infinity again, we're still going to get infinity over infinity, so we try one more time. And we do the derivative of 2x is 2. The derivative of 1 is 0. The derivative of negative 2x is negative 2. So then this limit is equal to 2 over negative 2, which is just negative 1. Now, another way you could have thought about that is that the degree of the top is a 2. The degree of the bottom is a 2. So there is a tie in terms of the degrees. So at infinity, what's going to happen is we're going to take the coefficients in front of those variables with the highest degree and just divide them. So we have 1 divided by negative 1, which is negative 1. And this is a horizontal asymptote, HA, at y equals negative 1. So infinite limits, for the most part, are just asking, is there a horizontal asymptote, and what is the horizontal asymptote? So you can review those horizontal asymptote rules.